Okay, so go ahead and get out your guys' notebooks, please. And can you all see my screen? No, not yet. All right, there we go. So now you guys can see my screen, correct? Okay. So again, you do not have to write this part down, but we're going to further talk about transformation of functions. And we're really going to be focusing on the vertex and what's happening. So we're going to take some of that information, and now we're going to be able to go off of that just a little bit. So yesterday we talked about something like this. So if I have y equals the value of x minus 2 plus 3, you guys all should be able to identify exactly what's going on. Let's see. I see Hannah Self. Can you unmute yourself? Sorry, I'm just going to pick a couple people. How is this being transformed from the parent?
It's being, isn't it moving to the left 3?
So not to the left 3. So remember, and this is just kind of.
Sorry, it's being, wait, is it down 2 and left 3 because of the.
All right, so you got that backwards just a little bit, and so that's kind of what I want to do. And I'm sorry, thank you for answering. I don't care if you're right or wrong. I need to kind of see what we get and don't get, and what I need to go over. So if we've got minus 2 with the x always moves it left and right, and it's the opposite of what's happening to the x. So on this one, I would just say, and sorry, let me get my pen ready. So on this one, describing the transformation, I would go ahead and say that this one right here has moved it right 2, and then the k part, this is your k value, and that does what it says it's doing, and that's going to be up 3.
Okay.
All right, and that's kind of what we did yesterday. So let me pick on somebody else. Sorry and I'm just kind of picking the people I see on my screen here. So Darius, either in your own words or mathematical terms, what does this negative sign do, Darius?
Don't like if it come out and make it like do you make it positive?
What do you mean make it positive? So just to run you through this again. So what the normal parent function looks like is something like this. Anytime I have this negative out in front, what's that do? Let's see, Darius took a chance, so let me ask somebody else. I see Catherine, you're in the top left, and I'll move off this screen. I'm not going to pick on you 6 every time. Catherine, what's this negative? What do you think it does?
Reflects.
That's right. It just reflects it or flips it over the x-axis. So anytime you have a negative, that just means that it opens down or it reflects it, and that's it. Okay, so those are the keys there that we had from yesterday. Now, one last thing here. What if I say it's being stretched? Oh, well, that's not what I meant to say. So anytime I have a coefficient, it's either being stretched or shrunk. So that's just talking about how steep, how fast it goes up, or how wide it is. Remember, if that coefficient, if you will, if that number being multiplied by the absolute value is greater than 1, it stretches it. It makes it bigger. All right. In this case, by making it bigger, it's just going to make it go up a lot quicker. If that were a fraction that's less than 1, like 1/3, now all of a sudden it's going to be a lot wider and it's going to look more like that. Okay, and that's it. So that's the heart of what we did yesterday. So let's take this even further. And here's what I want us to do. Let me go here. So this time I said write a graph, write an equation whose parent function is y equals the absolute value of x with the given transformation. So I do want you guys to take just a couple minutes and try this on your own. Again, this is where I would walk around the classroom and see if you get it. but see if you remember how to do this from yesterday. We will go over this in about 2 minutes. So the parent function is this. Here's the parent function. So what do I have to do to the x or outside the x to make it say it's going left 2 and up 3, so on and so forth. So just take 2 minutes and try this on your own. Make sure that you guys get this. About 1 more minute. If you're done, you can kind of take a break. Just a reminder, good morning. When you guys get in, please type in hi into the chat so I make sure that I count you present. Good morning. Make sure you take, or you say hi in the chat. Take a second and make sure you chat hi just so I can count you present. And a lot of times, if you miss more than the first 5 minutes, you might need to go back and watch the video. So we gotta go ahead and proceed as normal. So let's go ahead and get started. And I'm sorry if you guys are, if you're still working on this, but remember left and right always affects the x. So if I'm saying left 2, and I'm sorry for cold calling here, but Israel, you're on my screen here. So if I'm saying left 2, is this gonna be a +2 or a -2 with the x?
-2.
So that's what you would think it would be -2, and that's part of why I'm having you guys do this and make sure that you're kind of following along. It's easy to zone out a little bit. But what the x is, it's always going to be the opposite of what you would think. So if it's left 2, then it's going to be the opposite. So it would be +2. So in general, anytime we're doing transformations, it is always the opposite of what's happening to x. So the opposite of h. And then your k is what it says it is. So if it's up 3, then on the outside, I would just put +3. Now, with that said, I've got, again, I apologize for this, but I see Jasmine. So Jasmine, I've got y equals, and it says right 5 and down 4. So what's that going to look like?
-5 and then -4.
That's exactly right. All right. There you go. And I'm just trying to make sure that you guys all have a chance with me here that you can walk through this. Now, number 3, it says reflected over the x-axis. At the very end, we will talk about reflected over the y-axis. It's pretty simple. And then write 1 up 6. So number 3, I'm going to put down here. So again, I'm going to start with the parent function. Something kind of like this. All right. So reflected over the x-axis, I'm going to change screens here. So let's go with Anna. So Anna Charbonneau. Reflected over the x-axis means, what do I have to put?
A negative?
Good. A negative sign in front of the absolute value. Now it's being reflected. And right one would be what, Allison Smith?
-1.
Perfect. And then on the outside, it says up 6. So Caden Lesnick, what about up 6? Are you there, Caden? All right. How about you, Jalen?
+6.
Perfect. All right.
My bad.
You're all right. That's the problem with this. It's really easy to kind of zone out or just get caught listening. I want to make sure that you guys are active in this. So I'm going to do my best to, and when I say limit the homework, to make sure that I'm only giving you a couple of each type on the homework. So make sure you guys get this, because remember, right now your homework is 100% of your grade as of right now. So make sure that you guys are following along. Now, number 4, it says stretch by a factor of 4, left 3 and down 2. Let's see. Let's get somebody I haven't called on yet. Let's go with Latavia. I knew that. Latavia. So stretch by a factor of 4. Just read off what you got.
4, and then the little
Absolute values.
x plus 3 minus 2.
Minus 2. And that's exactly right. Okay. Well done. So once we have that, we are good. So any questions so far? All right. So we're going to get on to this a little bit better. Now let's go ahead and let's deal with some of these graphs. So this is identify the vertex and graph each function. Yesterday, we only graphed by making a table. You no longer have to make the table. And here's what I mean. So we're going to do all 3 of these together. And I want to make sure that you guys are with me here. So let me pull this back up. I'm going to call on Landon. So Landon, here I've got f of x. That just means the function. That's essentially f of x just y. So how would this be shifted? Up, down, left, or right 1?
The right one.
Right 1. So that's exactly right. It's the same thing. It's just been shifted right 1. Now, the whole concept of slope here is I look in front of this, there's no negative sign. So my absolute value is positive, which means it opens up. Has it been stretched or shrunk?
Not yet.
No, it hasn't been stretched or shrunk because what's in front of here, I don't see a number, so it's just 1. And that introduces the concept or the idea of slope. And remember, absolute values make V's. So I can graph all of these without making the table. So that's why it's important to know what the vertex is and how everything has been transformed. So if you know that something is going up, down, left, or right, and it's being stretched or shrunk, this starts to become very simple. So I'm glad that you guys have got this. My vertex is anywhere that it turns. So my vertex is 1, 0. Now we could get more mathematical with this and talk about it being something like the opposite of HK, but I think that gets, when we get ambiguous like this or in general, that starts to get a little bit, we miss the point, okay? We lose it. So let's look at this one right here. If we're trying to graph this and find the vertex, let me call on somebody else here. Let's see, Lizbeth, you just joined us, so welcome. Hopefully you're following along. So right here, and you can just tell me one at a time. Lizbeth, what is that negative sign doing?
Moving it to the left
Flipping
or to the right.
it over the x-axis.
Yeah, it's just flipping it or reflecting it. And I don't really even care how you say it, but it is reflecting over x-axis. So in other words, I kind of like when you say flip because that shows you what it's doing. In other words, I know that it's going to open down. Okay? So all that negative does is it reflects it over the x-axis or makes sure that it opens down. And you're going to hear me start to say stuff like that. All right. And again, I'm not trying to pick on you, but I want to see kind of where we are. That x minus 2 in the absolute values, is that moving it left or right?
To the right.
To the right 2. And what about this minus 3, up or down?
Down.
Down 3. So it is this simple. Your vertex is going to be the opposite of what you see here, -3. So it has been moved right 2 and down 1, 2, 3. And that negative sign is just a reflection over the x-axis, which basically means it just opens down. Notice my slope, there's no stretch, no shrink. So my slope this time is -1. And absolute values make v. So make sure you understand. Oh. You guys can see in just a day, look how much better my drawings are getting used to this. All right. Any questions so far?
Wait, so
Yep.
how did you figure out what the slope was?
So, and it's not really slope. I say slope because that's a term that you guys are familiar with, but your slope is always going to be what this coefficient is, or the number being multiplied by the absolute value. Okay.
Got it.
For instance, this last one might actually answer that. Let me erase this real quick. Hopefully you guys are following. And I know you guys are, some of you are writing this down, and I know I'm going kind of quick. I apologize. But let's look at this last one. So who was that asked about the slope?
Anna, hi.
Okay. So Anna, what's my coefficient for the absolute value? What is being multiplied by the absolute value?
-1/6.
So that's my slope. Does that make sense? That's it.
Yeah.
And because it's negative, does it open up or does it open down?
Opens down.
It opens down. Has it been moved left to right at all?
No.
No. So it hadn't moved left to right at all, but this +4 means it's moved up 4. So there's my vertex, 0, 1, 2, 3, 4. And then to apply my slope, it's -1/6. So here's the part I really need you guys to watch, and I understand how this is confusing at first. It works exactly the same as slope, but knowing that this is my vertex, which means this is where it turns. So it goes down 1 and it runs 1, 2, 3, 4, 5, 6. The absolute values make v, so it runs both ways. Again, normally in class, sorry, I was just bragging about how much better I've gotten, and that's terrible. But that's it. In class, I would give this to you guys as a handout, and we'd do it together. So just make sure that you're able to follow along. If you have any questions, let me know. Okay. So now that most people have that, remember, you can always go back and watch this also. Let's do this a little bit differently. Let's go ahead and look at this and see if we can write this. So let's write the equation. Let me see if I can blow this up just a little bit. There we go. That's a little bit better. Okay. So the first thing that I want you guys to see is, what is my vertex? So let's take a second here on number 1, and we can slow down just a little bit, and let's identify the vertex. So my vertex on number 1, remember your vertex is where it turns. So my vertex is -2 and then +1. So you're literally just looking to see, where does it hinge? Where does the graph turn? And it's at the point -2, 1. If we're writing an equation, now I haven't even addressed the quote unquote slope, if you will. So I'll leave that blank so far. Well, remember, in an ordered pair, this is your X and this is your Y. If it's moved left 2, is this going to be +2 or -2?
Plus.
And it's moved up 1, so it's plus 1. So this really starts to get pretty simple. Now, the last thing that we need to address is let's look at the slope. So my slope, and I can look at it positive or negative. I can look at either one of these points. Remember, absolute values make V's. So if it opens up, it has to be positive. You do not have to write a positive sign, but I want to make sure that you guys understand this. If it opens up, it is positive. If it opens down, it is negative. So what's my slope? It looks like I went up 1, 2, 3, and over 1. So it's 3 over 1 or just 3. And that's it.
So is the x value in like the vertex always the opposite of what's within the absolute value signs?
That's exactly right, Anna. It's always going to be the opposite. So once we really, really get into transformations, your vertex is known as H and K. So it's always going to be the opposite of what's right here. So if I see a -2, it's going to go as +2 every single time. I'm glad that you brought that up. Good question. All right. Now I'm going to give you guys not too much time. I'm going to give you about 30 seconds to try and write number 2, and then we'll go through number 2 together. Okay. Some of you guys have this, some of you might be waiting. So if I'm looking at the vertex, I've got 1, 2, 3, 4, 5. It looks like the vertex is at 5, -1, 4, 5, 6. So it looks like on this one, my vertex is at +5, -6. So somebody else, I've heard from the same couple people for the last question or two. Somebody else help me out. We'll ignore the slope for right now, but what's going to go in the absolute values? What are my H and K values here? What goes with the X?
-5.
Exactly. -5. And then what's my K value?
-6.
-6.
Perfect. Thank you guys. And I know you don't mean to talk over each other. I love the participation. Now, the last thing is the slope. So everybody sees how this opens down. That just means that this is negative. And my slope is down 1 over 2, down 1 over 2. So it's just going to be -1/2. Any questions? Okay. Try 3 and 4 on your own real quick. And then I'm going to go a little faster once we do this. So real quick, I'm going to give you about 2 minutes to do number 3 and 4. About 1 more minute. Sometimes it gets really hard to give that wait time here. I know some of you guys need it, some don't. All right, so I'm gonna go ahead and walk you guys through this. I'd normally open it up for participation, but I wanna give you guys a little time to ask questions, look at your homework, walk you through that. So my vertex here is negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So it looks like it is negative 5, 7. So it's always the opposite of what's going in here. So positive 5, the k value stays the same. Now we have to figure out our slope because it's opening down. And it's looks like it goes down 1 over 1. It's just negative 1. I don't have to put the 1. If you do put it, it's fine. So if you write negative 1 here, that's perfect. However, if you just want to keep it as negative, that's perfect also. So you won't ever see us, me, the book, you won't see any math teachers really write the negative 1 because you don't need it. Next one, my vertex looks like it is 0. And then down 1, 2, 3, 4, 5, 6, 7, 8. So 0, negative 8. So I can, of course, write plus 0 or minus 0, but I don't need that either. So it's just going to be minus 8. So if I don't see anything, it's going to be a 0. My slope looks like it is up 1, up 2, over 1, 2, 3. So 2/3, it opens up so it's positive. And that's the final answer. I'm going to clean that up just a little bit. It really should look like this. So remember, if it doesn't move, I don't have to, and you will never see, I don't have to put, and you will never see a plus 0 or minus 0 because you're not adding or subtracting anything here, and that's it, okay? So this is kind of the heart of the lesson of what we're doing today. There's one more thing I want to talk about. So yesterday I kept mentioning you have to say it's a reflection over the x-axis. So the reflection over the x-axis is if the negative is outside of the absolute value. Well, if you ever see a negative on the inside, that just means it's going to reflect it over the y-axis. Now, if you ever see something like this and you're confused how to graph it, just make a table. So this is funny because that actually looks exactly like this. This is the same as this. Now we'll get in more into that exploration another time. But if you're ever trying to reflect something in the y-axis, you're literally just changing the sign in front of the x in the absolute value. So that's all this is saying. Here's one example, and I'm only showing you this just so you're familiar with it. We'll talk more about this tomorrow. But you do have 2 assignments here where it says, I want you to reflect it across the y-axis, or 2 assignments, 2 questions on your assignment. So if this is what it says, and they just want you to show a reflection across the y-axis, it's this simple. Okay, so notice the difference. If I were reflecting it across the x-axis, the negative sign will be right here, outside the absolute values. It's reflected across the y-axis, the x becomes the opposite inside the absolute values, and that is it, okay? Any questions? It's pretty simple, but that's why we have to say how it's reflected or which axis it's reflected over. So I'm gonna go ahead and clear that off. Now, you guys have your first assignment on big ideas tonight. Let me do this real quick. Your first assignment, it's page, don't worry about the page, sorry. Old habits, I guess. It is assignment 1.2, number 3 through 18. So let's go ahead and bring this up. It's up already on your class resources, but go to big ideas. So let's see, if we go to big ideas, what you should see when you log in, it's this homework right here, the 1.2 homework 1. So it is assigned, it was assigned at 7:34. Oh, well, I need to change the due date actually. It's due by midnight, but go ahead and try and get that done tonight. It's due by midnight tomorrow. It says it's due at 7:34 a.m. But see if you have any questions, let me know. I forgot to change the time. I'm glad I checked that out. Okay. It is about 16 questions. Some of them are very simple. Some are a little more complex. I'm going to kind of cut you guys a little break with this at first until I make sure that I get this down. But make sure tomorrow when you come in, if you have any questions, and I mean any questions at all on the assignment, write down the problem and I will walk you through it tomorrow. Okay. So, any questions so far? All right, let's bring us all back together. Guys, I am finished for today. If you have any questions at all, make sure you email me. If you can't get on the book, email me right away. And on my prep period, I will get you guys in. We'll get you set up, okay? Again, try and do that homework assignment. You still have about 10 minutes left in this class. If you have not already, please make sure you write hi in the chat. You only have to do it once. Once I see your name, I'll mark you present, all right? That's it from me today, guys. Go ahead and start your assignment. Have a great day. See you guys tomorrow.
Thank you.
You're welcome.